this is what we're about to do here. This is actually still within that same section we were working on today in class. We talked today about finding the derivatives of functions using limits. And what we're going to do with this stuff is actually kind of work backwards, where instead of me giving you a function and a point, I'm going to actually give you the limit, and then you have to determine what the function and the point was. So we're going to kind of decipher a limit. We're going to have to look at the limit and kind of pick it apart and find the original function and the point of tangency where we're looking for the slope. And to do this, you have to know these two limit definitions of derivatives. This is the first one. This is kind of my preferred way when I'm finding the derivative, and that is this top one. This one right here, the bottom one, this is one that's used more frequently. In our book, if we're doing problems in our book, a lot of times instead of h, you will see delta x, which makes great sense graphically, because if you remember that long 25-minute video for the weekend, h represented the distance from the point of tangency to the secant point, which really is a change in x. That distance is a change in x, and we wanted that distance to approach 0. So the book is using delta x to represent some span of x values in that graphic that I was using over the weekend. So anyway, you need to know these two limits, and we're going to kind of pick apart the limits with real functions and points to find the function and the point of tangency. And here's one right here. We're going to start simple. Following limits represent the slope of a function at a given point. I want you to identify the function and the point of tangency. So here I'm giving you the limit. I'm not asking you to solve the limit. I don't care what the answer is. This limit represents some function and a point of tangency. And you have to decipher first which of these two limit definitions we're using. Are we using definition 1 or 2 here? And a lot of times it's pretty easy to tell because there's one where you have the limit as x approaches a of a bunch of garbly poo, and then you have the other one which is limit as h approaches 0 of a bunch of garbly poo, and this one clearly is not approaching 0, so we know we're looking at that top definition, which is f of x minus f of a over x minus a. And the beauty of this is when it's in this form, a, the point of tangency, is staring you in the face. So we know we're finding the tangent at some x coordinate of 3, and then we just need to find out what the function is, and that's pretty easy too, because in the numerator, the first piece is also the function. So my function is f of x equals x squared. So this problem right here, it looks like a limit, but what it's really asking you to do is to find the slope of the tangent to x squared at a equals 3. And at some point in your life, you will be able to simply look at that information right there and very quickly see that the answer is 6. And you don't even have to actually solve the limit. You can do it in your head. And that's I've shown you that I've done that a few times earlier in the year. And the trick is you identify the function, you identify the point of tangency, and then you can dive into some shortcuts to make the limit a lot easier. So there's number 1. Let's move on to another one. Number 2, again, this is x approaching 4, so I know I'm looking at this limit definition. The limit is x approaches a, f of x minus f of a over x minus a, and these are the easy ones because whatever x is approaching is your a value. So there's a. I know I'm finding the tangent at some x coordinate of 4, and my function, it's f of x minus f of a, and this one's not as clear, but I'm thinking this is my function. So I'm going to guess f of x is x squared minus 2x. And the only way I'm going to check that is I'm going to go into thinking land just to make sure this works. And if I did pick my function and point correctly, then when I plug my point into my function, that's 4 squared minus 2 times 4. That does give me 8, and that's exactly what I'm subtracting because I'm supposed to be subtracting f of my point. So when I plug in 4 to that, I do get 8. So I'm confident that this is correct. And again, real quick, I'll do this in my head. Your answer is 6. Again, that's kind of coincidental because that was the last answer. But once you identify the function and you identify the point, you can very quickly figure out what the actual answer is as far as the slope of the tangent. Let's see, number 3 here, getting a little bit more complicated because this time, if you notice, it's the limit as h approaches 0. That means I'm not using this definition. The definition I use in 2. I'm using the limit as h approaches 0, and we know that the limit is f of x plus h minus f of x all over h. Now this one's a little bit tough because I don't have my function staring me in my face the same way I did on numbers 1 and 2. But what I do recognize is that instead of x plus h, I have 7 plus h. So what I've done with number 3 is I've taken out the x's and I plugged 7 in for the x's. Well, what that means is that I'm finding the point of tangency at 7. I've gone ahead and plugged in 7 for my x. So I know I'm finding the tangent at 7. And then I'll look at this piece right here. This pretty much tells me what my function is, except instead of 7, or instead of x, I've plugged in 7. So based on that, I know that my function is 2 times x to the 3rd power. So there's f of x, and if you want to double check it, if I plugged in x plus h, it'd be 2 times x plus h cubed, 2 times something plus h cubed, and I'm confident that I have the correct function and the correct point. And this one, oh geez, I can't do this one in my head. It's 6 times 49. What's 6 times 49? Geez, I don't know. 49 times 6, that's 54, carry my 5, 294. So very quickly I was able to answer this limit. I know the answer is 294 because I have the ability to look at the limit and pick out my function and the point of tangency. Once you pick out the function and the point of tangency, then you can very quickly answer some of these limits without having to go through the pain of cubing all of this out or trying to factor it or anything like that. Let's see, moving on. Number 4 looks like the exact same limit. The limit as h is approaching 0 of f of x plus h, minus f of x all over h. I'm looking here, and this one's a little bit tricky. I have that sine something here. It's sine of something plus h. I'm thinking pi over 6 is taking the place of my x. So my tangent is going to occur at the point x equals pi over 6. And then identifying my function, remember, this thing right here is supposed to be f of wherever my point of tangency is. So that's f of pi over 6 gives me 1/2. And I see sine of some stuff. Let's see, sine of stuff minus 1/2. I'm thinking my function, f of x, is going to be sine of x. And then I'm going to check that real quick. This is supposed to be f of pi over 6. If I plug in pi over 6, sine of pi over 6 is 1/2. So there we go. And again, using the shortcut, now that I know the function and the point of tangency, I know the answer is going to be root 3 over 2. Very easy to do once you know shortcuts. So that's why you need to be able to identify these functions. It allows you to answer limits quickly. Let's see, moving on to 5, exact same definition. H is approaching 0. I see the square root of some stuff. I see square root of stuff. So I'm thinking that square root of stuff is my function. So my function is most likely square root of stuff, square root of x. And then this thing is f of whatever I think my value is. Let's see, it looks like I've taken out the x. Instead of x plus h, I have 4 plus h. So I'm thinking my x coordinate of tangency is 4. And let's see, f of 4, the square root of 4 is 2, so that checks out okay. There's my function and my point. Shortcut real quick, see if I can do this. It's going to be 1/4 when you work that out. So there we go. There's your function, there's your point. And then there's one other way I'm going to change it up, and this next part's even easier. And I probably should have done this next part first. So we identify the function and the point of tangency, and that allows you to go into derivative shortcuts to answer the limit, which you don't know shortcuts yet, so I'm just teasing you. I have a few more examples. This time, I'm giving you the limit that represents just the generic function f prime of x. I'm not plugging in any kind of a point. I'm simply saying, here's the limit. What is the function where I'm finding the derivative of it? So f of x, and you just simply have to identify what limit definition we're doing. This is clearly as h is approaching 0 of f of x plus h minus f of x all over h. And if you're not plugging in numbers for h, it is painfully easy. I see tangent x plus h minus tangent x. There's my function. So this limit actually represents the derivative of tangent x, and at some point in your life, you will know, and this is one we're going to memorize, but you'll just know that the derivative of tangent is secant squared. Now, if you were going to try to solve this limit without knowing your derivative shortcuts, you would have to go into some crazy angle sum or angle addition identities, do some canceling. It would be really painful. So that's why it's very important for you to be able to decipher what is the function that we're playing with for these limits. We have 2 more of these, and then we'll call it quits. How much time have I spent on this? 10 minutes. Not too bad. Let's see, number 7, getting a little bit fuzzier. It's still h approaching 0. So again, limit as h approaches 0, f of x plus h minus f of x all over h. Now, if I gave you this limit, it's very, very intimidating and daunting. But once you learn derivative shortcuts, this is very easy as long as you can identify the function. I see x plus h, and a 4, and then I see minus all of this stuff. I'm thinking all of this represents f of x plus h minus, and then this stuff right here represents my f of x. So this thing represents f prime of x, where my function is x cubed minus 3x. And then you can do the derivative of that very quickly in your head once you learn derivative shortcuts. But for now, all I want you to do is pick out what is the function. One last one, exact same limit definition. H is approaching 0, so we're still thinking about this thing over here. I see something in terms of x plus h minus something in terms of x. That second one is your f of x. So in this case, f of x is 3 over x to the 4th. And once you are capable of identifying that function, the derivative is very quick. This one, the derivative is going to be what? Negative 12 over x to the 5th, I think. Yep, that's right. So learn to identify your function and the point of tangency in a limit, because otherwise solving limits can be very painful. There you go. We'll hammer this out in class.